YouTube. Mr. King coming at you live from the studio. Here are the questions for the day. Please pause the video now and answer them. Next, so remember, all elements have a drive. They really want to complete orbitals. So like for example, lithium, which is a metal on the left side of the periodic table, it has one valence electron, just one. And it wants to be like this. So it's a lot easier for lithium to be stable if it loses an electron. So it doesn't hold on to that electron very tight. But fluorine is the opposite. Fluorine has 7 valence electrons and it's very close to being complete, looking like this. And fluorine is just 1 electron away from being complete and stable. So it'll try very hard to get that extra electron. And it's the same with oxygen. Oxygen almost has a full set of valence electrons. It just needs one more right here and one more right here. So that's the idea. As you can see, all the elements in this column need 1 valence electron. All these ones need 2. All these ones need 3. These ones can go either way. They're typically halfy since they're half full. These ones will lose 3. These ones will lose 2 valence electrons. These ones will lose 1 valence electron. So they can be in this column and stable. Okay? And remember, the inner ring usually is close to the nucleus, so it'll be stronger. So the closer the rings are to the nucleus, the stronger they are because they're harder to steal from. Because they're close to the nucleus, the positive attracts the electron out here. That's the idea. Here's some announcements. Please pause the video now. And today we're gonna go over the practice test. Okay? Let's pull up Monday. Practice exam. I'm gonna show you how to do each one. Okay, number 1, identify the following elements using the periodic table. So the first one, I see oxygen right here. But remember, the electrons and the neutrons are variable. So it's the protons that makes an element. So this element has 8 protons. So if I had 8 in the periodic table, 8 is O. You probably know that O stands for oxygen, but if you want to, you can look it up. And I'll give you oxygen. So that element is oxygen. Let's do it with a harder one. This one's uranium. Super huge, super famous for radioactivity. Has a ton of electrons. Don't waste your time counting those. Only count the protons. So this is 92 protons. So find 92 in the table. 92 is U right there. I already spoiled the answer. He's telling you it was uranium. That's the idea. You look at the neutrons and then look it up in the periodic table. Next one, examine the Bohr model of lithium below and explain why are neutrons necessary for the atom to be stable. Hint, consider what would happen if it was only electrons and protons in the atom. So remember, if you would have watched the video or looked at your notes, you should remember that neutrons are necessary because the protons and electrons are attracted to each other because they are positive and negative. So in order to be stable, the atom needs something neutral in between. So the atom doesn't collapse, or so the protons and electrons don't collide. It wants to hold the protons there and keep them from spreading out and getting with their electrons that they love. So the neutrons are meant as like a shield. And I use an analogy. What would you do if you were trying to stop two things from colliding with each other? You'd want to put something in the middle, like a neutron. This water bottle would be the neutron, stopping the protons and electrons from hitting each other. That's the idea there. Next one, how are elements able to make different colors? If you look at the GIF, as you can see, when atoms absorb energy, a valence electron jumps up, and then when the valence electron jumps back down, light energy is released. So when elements release energy, light is released. Some of that energy is released in light, but the reason why they can make different colors, the idea behind fireworks, because different elements absorb and release different amounts of energy. They all take in and release different amounts of energy. And sodium won't release the same amount of energy as chlorine. So, knowing that, remember that colors of light have different amounts of energy. So, different elements get you different colors because they release different amounts of energy. That's the idea. This is extra, but remember the acronym Roy G. Biv that you learned as a child for the rainbow? Well, it also gets the order of energy. So red has least energy, and violet has the most energy. Okay? That's the idea. So an atom or an element that doesn't release very much energy would release red, whereas an element that releases a lot more energy would release violet colors. That's the idea. All right, next one. Congratulations. It is the year 2040 and you need to clean your new indoor pool. In order to clean the pool, you need to find the chlorine-35 isotope to kill bacteria and other pathogens. Answer the following questions to ensure you have the right element. So start off, chlorine is element number 17. So if it's element number 17, that's the atomic number, and it has 17 protons. And chlorine-35 gets its name because it weighs 35. So how many neutrons does it have? Well, you take the total mass, 35, minus the protons to get 18 neutrons. That's what makes up the other weight. Next one, how many electrons does chlorine-35 have? Well, I didn't say it has a charge, so you have to assume protons match electrons. So it's balanced. That's how you do that one. This next one is review from our notes. So it's asking, why do atoms get bigger as you go down and to the left? So the reason why they get bigger as you go down is they have more orbitals the further down you go. Also, they're larger on the left side because there is less attractive force or electronegativity on the left side. Yep, so francium, rubidium, potassium, sodium, they have very weak attractive force. They don't really hold themselves very tight. They're much more spread out because they don't want any more electrons. They want to get rid of them, so they're more spread out. Now you're doing the opposite. Why do atoms have more ionization energy and stronger electronegativity as you go up and to the right? We did this in the notes last week. The reason is, as you move up, the elements are smaller. So the orbitals are smaller. Closer to the nucleus, which makes them stronger. They want electrons more, and they're going to be harder to steal from. The reason why they get stronger as you go to the right, those elements want to steal electrons to complete their orbital, usually so they can have 8 valence electrons. So that's the idea. So remember, all elements want to be like this. They want to have a complete orbital. But the elements on the left side, they want to lose electrons. So they're not going to be very strong. They want to lose them. Whereas all these elements, they want to gain electrons so they can be complete. So that's the idea. That's why they're stronger on the right side, because they need to steal those electrons. That's the last one. After you're done with that, please hit turn in and take the 10 survey for the day. After that, you're all good to go. Thank you so much, everyone, for staying with me. See you on Thursday.